Hello and welcome to GDA Conversations. My name is Raj Hajaria, Technical Manager with Gulf Downstream Association. GDA Conversation is an ongoing series in which we are talking to the industry leaders and subject matter experts on the topics of common industry interest. Today we have brought you speakers from ASTM International. ASTM International was formerly known as American Society for Testing and Material. And as you are aware, ASTM doesn't need any introduction. It's a not-for-profit entity. It's also a knowledge partner for GDA. And they have more than 13,000 international standards which deals with improving product quality, enhancing safety, facilitating market reach, and also building consumer confidence. We have from ASTM 3 experts featuring in today's conversation. Bryan Johnson, Mindy Villalba, and Lisa Williams. Bryan Johnson has a 29 years of experience as a plant reliability engineer at Palo Verde generating station. He is the chair of ASTM subcommittee on condition monitoring of in-service lubricants. He is also the chairman of the board for International Council for Machinery Lubrication. And last but not the least, he is also an advisory board member of Auburn University, from where he secured his mechanical engineering degree. Our second speaker, Mindy Villalba. She has 13 years of experience with SGS Laboratories in managing specialty projects. She is also vice chair of ASTM Turbine Oil Subcommittee. And she is a specialist in unknown residue analysis and particle characterization in the lubricant industry. Our third speaker, Lisa Williams, also has 13 years of experience as a solution provider in reliability engineering and tribology. She is a specialist in lubricant analysis, and she is also a vice chair with the ASTM Committee for in-service lubricant testing and practices. Lisa is not able to join us in today's conversation due to an emergency which happened with her a day before, and we apologize. These speakers from ASTM have chosen a very interesting topic, which is ASTM and lubricant condition monitoring, using best data to make best machine decisions. This reminds me of the beginning of computer age, when we used to coin a term called GIGO, garbage in, garbage out. So if you put the bad quality data, you get the bad quality result. Perhaps they would be talking about such things when we are moving into Industrial Revolution 4, where a lot of decisions will be made by machines and artificial intelligence. But to ensure that those decisions are accurate, practical, and reliable, we need to take care of the data. And probably today the speakers will highlight, and I'm sure we will all benefit from their discussion, how can we improve and accurately measure our data quality so that we improve the decisions made by the machines. So without further ado, may I invite and welcome our two speakers who are present today for this conversation, Bryan Johnson and Mindy Villalba. Hello, Brian. Hello, Mindy. How are you?
Hi, Raj. I'm doing well.
Very good. Very good. So, Brian and Mindy, over to you. I don't know who want to take the lead. You can start your presentation, and we will look forward to hearing from you.
Yes, I would like to thank the GDA for inviting us to participate in this event. I have had the opportunity over the last few months to be part of one of your committees, and I've been really quite impressed with the discussions and the vigor and all of the information that is flowing within that committee. So thank you very much for that. What I'd like to do with my introduction, and I'd like to thank Raj initially. Your introduction of ASTM was very, very extensive and very good. I would like to add a little bit more information to that, and this will be on the next slide. And what I'd like to comment on is that ASTM does have a paid staff that manages the process of the standards, but the individuals that develop the standards and vet the wording for the standards and participate in all of the activities to make sure that the standards are accurate and good are actually volunteers. So what ASTM does is that ASTM has periodic meetings for our group. For example, we meet twice a year where ASTM will host a site, and our group will come together and we will conduct the business of condition monitoring and work toward our standards. So all of us are volunteers. Some of us would be considered industry experts, but that is not a requirement to be part of ASTM. Rather, it's important that volunteers participate from all venues and from all experience levels. Our group, for example, has many end users, and these end users may not have quite the depth of technical experience of some of the experts, but they can come into the group and say, this is what we need to be able to run our business and to be effective in our processes. So we are very inclusive. We welcome people. We have a very open and I believe productive environment. And certainly all of you within the GDA, or any of you within the GDA that would care to join in and meet new friends and participate in making the condition monitoring industry stronger, we would be happy to welcome you to do that. So at this point, other comment I'd like to make is that the way we structured this is that we have a picture at the bottom of each of the slides, and this picture was intended to show who was speaking. We didn't realize that we would also have a live video feed. And so again, we feel bad that we can't have Lisa Williams with us. Her picture is on some of the slides, and she worked very hard to develop these and share these, and we appreciate your understanding. So I will, let's go ahead and turn the slide, and we'll turn the presentation over to Mindy.
Everybody, yes, my name is Mindy Villalba, and in these next few slides, I'll be speaking on behalf of Lisa today. But I wanted to kind of expand on what Bryan discussed with ASTM and sort of give you a background into ASTM methods, how they're created and how they're used. ASTM International, they develop a range of consensus standards that are adopted and used globally across many industries. The standards are designed by ASTM not only to enhance safety, but also to improve the quality of consumer and industrial products. Now, how a standard is initiated is when an industry sees a need to develop a method, then the companies in that industry come together under ASTM in order to achieve that desired result. ASTM methods, they have a short informative description of a procedure that is used to determine a particular property of a material. And the test method will include details about the test apparatus, the test specimen, the test procedure, calculations of data obtained, and all of this is in order to achieve satisfactory precision. So using one test method to evaluate a particular property or a set of properties, it becomes easier to compare and determine which product is best suited for a particular application. And we'll discuss a little bit how the precision of testing applies to used oil condition monitoring in the coming slides. Now, there can be multiple instruments or techniques that are available to review one simple property of the material. However, each method could contain various uses of solvents, temperature, instruments, and other testing parameters needed to reach that desired result. So when using multiple methods, it becomes very difficult to compare that property across multiple products or to determine variability that may exist. Using other methods that were developed internally by a specific company or another entity, they may not offer the information necessary to replicate the procedure elsewhere. The use of data from non-industry consensus formats that introduces uncertainty into test results. And because data from the source cannot be readily compared to standardized data, then the quality of that data is unknown. So the user of the test data can easily fall into a trap of thinking that the data provided is offering good information when in fact it really is not. If you've ever attended an ASTM committee meeting, then you know that one thing they're really good at, and that's covering all the details. Every facet of the procedure is identified and controlled in order to understand the precision and variability of the method. Such procedural factors may include the test instrument, solvents to be used, sample technique, sample preparation techniques, environmental parameters like temperature and humidity, and even simple parameters such as test time. Calibration of the instrument is also taken into account. Ensuring that these parameters are controlled up front, this not only helps control the data output, but it also makes the transition for new operators of the test method an easy implementation. The goal for understanding standardized tests allows the user to perform testing at various locations without seeing a huge deviation in the data. So what happens when a user relies on non-standardized tests is that they may see a vast change in the data and they may think that there's an issue directly related to the sample. The user may think that an adverse situation is occurring when actually it's the variability in the test method that is causing the issue. On the other hand, the data may appear to repeat nicely when in fact the data is completely wrong. In either situation, the users may find themselves taking steps into maintenance actions that are not warranted or that are extremely overdue. So good quality data is the key in understanding data trends. But how do you know if you are getting good data? Well, data bias is defined as the difference between what you expect to get for a test result and the result of a known accepted reference value. A known value in this case serves as an agreed upon reference for comparison. And we can come about a reference in a few different ways. It can be theoretical, or an established value based on scientific principles. An example of this would be utilizing density of water. The reference can also be an assigned or certified value that is based on experimental work of a national or an international organization. An example of this type of material would be an NIST or NIST standard. The reference can also be a consensus or a certified value that is based on experimental work of a collaborative group of scientific or engineering group. And examples of these references could be your over-the-counter CRM material. Now, a statement of bias in a test method provides guidelines on the relationship between a set of typical test results that are produced by a method under a specific test condition and how it relates to a set of accepted reference values. A test method should establish any bias so that it can be factored into the precision of the method, which is how close we can get independent results to agree. In terms of our discussion today, accuracy of a result is how close the test value is to an accepted reference value. Our goal for any method is to find ourselves in the top right bullseye, where the method and research data for the method produce zero bias with the highest results, with the highest precision under those test conditions. This would yield a high accuracy of test results. The least ideal situation is shown at the bottom right, where there is no determined bias and a very low precision. At this point, the test method and or the technique used may need to be reviewed and likely revamped completely. The other two situations shown on the left, although they're not ideal in that they produce a low accuracy of results, at least we have a known bias that we can account for, such as in a calculation or in a calibration curve. When applied to a set of results, accuracy involves a combination of a random component and of a common systematic error, which is that bias component. When an accepted reference value is not available, the bias component cannot be established. So I really want to point out here that 3 out of 4 of these data scenarios can really fool you into thinking that you have produced good data, when in fact, good data is not being produced at all. ASTM methods and processes take into account this need to incorporate precision in order to produce quality data. To establish precision, ASTM methods will specify control over certain factors, as I've mentioned before, such as the test equipment, the test environment, the qualifications of the operator, the preparation of the specimens, and the operating procedure for using the equipment. The test method will also specify the number of samples required and how many measurements on them are needed to provide a test result. Authors of the ASTM method will provide instructions or requirements for every known outside influence. Precision statements for ASTM methods are applicable to compare between test results under prescribed test conditions. It is not the intention of a precision statement to compare separate methods. So 2 precision conditions applicable to ASTM test methods are repeatability conditions and reproducibility conditions. Repeatability is the precision that is determined from multiple test results, where the test method is conducted by one single well-trained operator using one set of equipment in a short period of time, during which neither the equipment nor the environment is likely to change. Any variability is due to small changes in conducting the test operation and possibly by variation of the test sample itself. These changes are kept to a minimum by use of proper sampling procedures in the sample preparation. All sources of variability must be carefully controlled within the tolerances specified in the method. Now, as you've heard, these sources of variability may include a test operator, test environment, test specimens, and test instruments. On the other hand, reproducibility is precision that is determined from multiple test results, where the test method is conducted in several laboratories, each with its own operator, apparatus, and environmental conditions. They obtain test results on randomly selected test samples from the same reasonably uniform material. Reproducibility is the precision used when comparing test data across laboratories. It is also the precision used when comparing data from the same test specimen that has been produced at a much later time. In the case of condition monitoring testing, this scenario occurs when you retest another sample that is submitted from the same unit to confirm an oil property. The form and style for ASTM standards requires that all test methods include a statement of precision and bias. This allows potential users to generally assess its usefulness with respect to the variability in proposed applications. A statement of precision is not intended to exhibit values that can be exactly duplicated in every laboratory. Instead, the statement provides guidelines as to the magnitude of variability that can be expected between test results when the method is used in 1 or 2 or more reasonably competent laboratories. ASTM methods obtain these precision statements by the use of a rigorous interlaboratory study, also known as an ILS. An ILS involves the use of multiple laboratory each generating replicate test results on one or more materials. And from this data, precision information regarding repeatability and reproducibility can be obtained. Generally, it could take around 12 laboratories or more to produce the required amount of statistically viable information, which, as you can imagine, is quite a feat to maneuver in this volunteer organization. But producing test methods in this manner is exactly why using ASTM methods is so beneficial.
So what I'd like to do is step back a little bit and talk about maintenance in general, because condition monitoring is a piece of a maintenance strategy. So a maintenance strategy has three components, one of which would be time-driven maintenance, one of which would be corrective maintenance when something breaks. Then, of course, condition monitoring is somewhere in the middle. So one of the things that condition monitoring does is, in fact, maintenance in general would need to do would be to focus on a failure mode. So if we do maintenance at all on any machine, we would need to have a reason to do it. We would need to have an expectation based upon risk and reliability needed of the machine to spend maintenance dollars to ensure that the machine meets that expectation. So in doing this, a maintenance program may have 10 or 15 different items that are routinely done on the machine on a repetitive time basis to ensure the machine runs. So of course, when it fails, then we move into corrective maintenance and do a repair. So what condition monitoring does is it sits kind of in the middle. So through the use of predictive technologies and other condition monitoring techniques, the plant initially is able to look at those 10 or 20 items that have been routinely done on a time-driven basis and determine the failure modes associated with each of those items, i.e. what would we be trying to mitigate, what part of the machine are we trying to renew with the maintenance, and then apply condition monitoring. And in essence, what we would do is we would be able to delete some time-driven maintenance and defer that directly to the condition monitoring. So when we do this, the first thing that condition monitoring will do for us is it will reduce the overall amount of repetitive maintenance that we need to do, and it will place that directly into the hands of the condition monitoring team. So our discussion today is focusing on oil analysis, and oil analysis would be one of the primary condition monitoring techniques that is employed globally, typically on rotating machinery, because rotating machinery needs to be lubricated. So how broad is this across the globe? One could estimate 60 or 70% of industrial facilities in the world are employing oil analysis at some level. So it is very, very broadly done. Now, how it's done is another issue, and that's something we're going to talk about in greater depth through the remainder of this discussion. Okay, so oil analysis focuses on three primary elements of the machine or of the maintenance strategy. The one that's very obvious would be the wear of the machine. So as a machine wears, the components that are being lubricated and that are wearing will deposit tiny particles into the oil. And these particles are extracted with an oil sample, and they are tested and measured. And the information gained from the testing is then used to draw a position on the viability of the machine. In most cases, the position will be that the machine is normal. In some cases, it may be that increased monitoring is needed, or simply that the machine needs to be watched with normal intervals. And of course, the other alternative would be that the machine begins to break. Another primary area would be chemistry. And when you think of chemistry and oil, what you're really talking about is the oil itself. So one very important condition monitoring element that a program will do is determine if the oil is performing acceptably. And evidence of wear can exhibit itself within an oil sample and indicate that the oil film is not thick enough. So that would be immediate feedback that perhaps a higher viscosity oil might be needed. Also, in terms of chemistry of the oil, the additives used in the oil are there to enhance the performance of the oil, one of which would be how long the oil lasts. So condition monitoring would be used to basically extend the length of time that an oil may stay in service with the basic premise of why replace the oil if the oil is performing acceptably. The third is maybe not quite as obvious, the contamination point. So oil analysis, one of its primary reasons for doing oil analysis would be to maintain the engineered surface of the machine. So the original design of the machine would have a surface finish, and if the correct oil is in place and that oil is clean, the surface is protected, and when it's protected, then the surface does not undergo downstream issues such as fatigue and other surface disruptions that could shorten the life of the machine. So the contamination control is very important because the cleaner oil will make the machine last longer. Okay, so there is an economic case for condition monitoring. I had mentioned one of them on the front end, and that would be that as a program is put in place, the facility should take a look at what maintenance is currently done on the machine and determine which of those items is associated to a particular failure mode that oil analysis may be able to address. And so rather than going in every 6 months or 12 months and doing those 3 or 5 activities, those 3 or 5 activities can be deferred to the oil sample and simply not be performed until the issue, until an issue becomes evident. So that's a very important part. The other half of this would be that the oil analysis will allow the machine to stay in service longer with the knowledge that the machine is performing adequately, meeting its expectations. And what this does is it increases the availability of the machine. And as we all know, if a machine is running, then the facility is better able to generate income by supporting the process that the industry is trying to pursue. So that would be a very important part. The third piece of this would be that when an issue is identified that requires repair, the facility, if the condition monitoring is correctly approached, the facility is in a unique position to be able to forecast when the repair might be needed. So many of the issues that an oil program will pick up start with tiny, tiny particles, and these begin to get larger and more of them begin to form. And through knowledge of the machine, the practitioner can then estimate that the bearing, the gearbox, the gears, whatever it might be, should be expected to perform acceptably for the next 6 months, for the next 3 months, for some future interval. And this is nice because then the repairs that are needed can be scheduled and put into an available work window, which again protects the availability of the machine. So all of these things taken together, and to include not having a catastrophic online that causes a disruption and alters the productivity of the facility, all of these things can be calculated and used to help justify a oil analysis program. This is kind of an interesting chart if you take a look at it. Any failure that occurs will start at some point where you can begin to pick up the data, and the oil analysis picks up the data much earlier than a vibration program would pick it up. So the idea would be that for the failure modes that the oil analysis program is monitoring, and we need to be clear, just because we have an oil analysis program or a vibration program or a thermography program, that doesn't mean that these technologies are able to pick up all failure mechanisms. So part of this process is to analyze which failure mechanisms are being protected and the progression of them, time from onset to catastrophic failure, and ensure that data is obtained somewhere within that range so that the pending failure can be picked up and appropriately managed. So this leads to one of the important elements of our presentation, and that is basically how do you get the data. So we've talked about using ASTM branded standards as our mechanism to ensure that we get good data so we can make good decisions. So how do we practically actually get this good data? And there are actually two options that have emerged over the last several years where a facility can make decisions and determine what would best suit them. Now, for me and my environment would be to have an in-house laboratory making use of off-site testing. But that is just the one option. So we're going to speak about both of these options as we continue on with this presentation.
Thanks, this is Mindy again. Yeah, there are many benefits to using a commercial laboratory for off-site testing and analysis. I'll go through each of these start items here in more detail, but just an overview. Working with a laboratory that has locations all over the world with an expansive testing capability, commercial labs will generally have multiple industry accreditations with rigorous quality assurance. Data obtained from a commercial lab is usually unbiased and objective to the tests that are being performed. Off-site labs will have dedicated staff to offer expertise and consult on new and ongoing issues. Commercial labs can offer a platform to review data collection and help trend various data sources. And off-site facilities can generally meet a required turnaround time of test results within a negotiated price range to help keep testing fiscally viable. So commercial laboratories are generally able to provide a multitude of testing capabilities that may span way beyond a specific need or a requirement. With each test, however, comes the need to provide accurate and reliable test results. As we've mentioned previously, if the test methods are based on ASTM standards, then there is already precision and bias taken into account when the data is reported. Accuracy of the test data is usually maintained by various quality control systems that a laboratory may have in place, and these are generally governed by established quality systems such as ISO 9001 or ISO 17025. One use of quality control in these systems for many labs is to verify data against ASTM standards, which may include certified reference material. If you find that there is a large variance between labs for a given test, then it may be useful to know what standards are being used by the labs if required. Utilizing standards where possible, I'm not quite finished, but almost. Using those standards where possible allows for the labs to easily be audited by customers and other entities. And the labs may be able to show the test data as it compares to other labs and sometimes referred to other laboratory studies, which we call round robins. And for those studies, the data will likely be pretty uniform and easily validated. And quality assurance programs, which have good quality controls in place, will even allow a laboratory to defend in court how a test result was obtained and reported. The objectivity that comes with establishing good quality controls is also a great benefit of utilizing a commercial lab. By utilizing ASTM standards, the off-site facility can remain unbiased in the data collection process and stick to reporting just the facts. When these facts lead into unexplained issues, a commercial lab will have experienced staff on hand to answer questions about unexpected data. This ability to consult with the end user offers them an avenue of resources to their team when exploring a potential threat to an asset. Many of the experts at a condition monitoring lab will have the appropriate experience and certifications to review scenarios related to sampling, testing, data management, and providing solutions. The experts may be able to offer suggestions for research that hadn't been thought of, or they may be able to help innovate new processes and techniques. Sometimes the research projects are of significant use to the end user. However, the user is not able to manage those complex experiments. And because many commercial labs perform various ASTM methods and practices, they become a great liaison to the end user for active ASTM methods that are best suited to meet their needs. And finally, a commercial lab will generally have a great software platform to help manage the flow of data. These software platforms would normally be available to plants and facilities at a large cost, but an off-site lab will usually have a way for the site to engage in the program, which is designed to do a multitude of tasks, such as report test data, allow the user to download specific or all test data, allow the user to compare trending of data across various units or fleets, and it can even create simple labels for sample submittal. Plants and other facilities can easily work with a commercial laboratory to create a useful test package or multiple test packages at a reasonable cost, which will provide data in a reasonable capacity. And for these reasons, and there's likely many more, the support of an off-site testing facility can be extremely beneficial.
Transition to on-site oil analysis. As I mentioned before, our facility has experience both with the use of an on-site and an off-site testing option. The on-site testing option has some particular advantages over the commercial, and part of this is how we develop people and getting data back quickly. So we're going to explore a little bit deeper about feedback. We're going to talk about stakeholder knowledge, development of personnel, how a program might grow if the testing is done on site and the availability of the instruments is local. And then finally, thankfully, there are commercial laboratories available, and the commercial laboratories can also be employed to pick up the enhanced testing or the additional testing that an on-site capability may not have. So one of the primary benefits of having an on-site laboratory would be immediate feedback. So I have experiences in my facility where my mechanics are out taking an oil sample. When they take the oil sample, the color is off to them, or they believe they see a streak, or they have some other concern about the machines, or perhaps operations has a concern about the machines. And having an on-site capability means that we can obtain a sample either because we have a concern about a machine or as a routine matter, and we can process it immediately and have a same-day position to the plant. So there are two parts of this. The one part would be to identify machine problems, but what I found almost as useful is that when these questions arise, the oil looks dark, we think we heard a noise, we have some other concern, that oil sample can be processed very quickly, and the feedback to the plant is that the machine is functioning properly and we don't have a concern about its availability. And to me, this has been a very, very powerful benefit, this immediate feedback of we don't have a problem. The direct knowledge part, I think, is something that can be overlooked. So when a facility has an online or an on-site testing program, what they have to do is they have to process their own samples. And as they process the samples, the technicians or engineer or however the plant is structured that does this work has also an immediate feedback from sensory issues. The sample smells bad, the color is bad, and that can be immediately turned into machine type information. So the people on site have the best understanding of their machines and have maintenance history and know what concerns the facility might have. And this testing feedback, as the practitioner is doing the testing, is very valuable because that person begins to obtain a deeper insight as to what the data might mean and a better understanding of the data, which in turn can help them when they make a recommendation to the facility about what is needed and what needs to be done. So cost benefits associated with on-site, so that there is a very clear benefit to a facility from a cost standpoint, having both on-site or off-site testing, And it's been demonstrated that having an active program costs less than the savings realized from increased availability and better management of maintenance practices and machine performance. So that part is there for both of the programs. For a on-site program, however, what I've seen is that having a capability available, we define a scope of a program, but as the mechanics and operators and plant become very familiar with the capability, that capability becomes cultural to the facility and other samples begin to arrive. So it is very common that a starting program will grow and develop and become larger, and it does so simply because the value of the testing becomes more obvious to the organization, and that single point encourages through a broader use of the technology, encourages more testing and more testing on more machines, which increases the benefit. So another part about this would be, and I mentioned this, that commercial labs are going to be needed if you have an on-site strategy. And that would be because some of the tests that would still be required, you know, and I'd estimate that we can get somewhere in the area of 85 to 95% of our needs out of an on-site testing program. But the commercial laboratories have the capability to do many, many more tests. And for those tests that are not frequently performed, we have the additional advantage of being able to rely on their expertise with the interpretation. So what I've seen is the tests that we do all the time, and as we begin to understand our machines better, those we have down and those we understand. But that same statement can't be applied to tests that are infrequently performed. So I'd like to briefly compare these two options, and I will say initially that both these options are very good options. I will also say that for these options to work well, the practitioner would want to use tests or instruments that are within the ASTM family. The points that Mindy made earlier about data quality and data precision apply, and both these options have tests and instruments available where one can get the good data that ASTM might offer. So the first point would be available test methods. So a commercial laboratory has many more choices than an on-site laboratory would have. So it would obviously have an advantage in that regard. But an on-site testing capability is able to meet most of its needs. And of course, having a commercial partner available is very important because these samples can be sent out. Now, another point on this is that an on-site laboratory may identify a machine issue, and due to importance or other business reasons, the facility may decide to send the sample to their off-site partner anyway to get a second opinion. Often having that second opinion is very important when drilling in on the decision to take something out of service or to take an outage or not. So that's a very valuable benefit. Database trending, the commercial laboratories, some of these laboratories see thousands and thousands of samples a day. And with just the very large population, they are able to build big databases of common machines. And statistically, they are able to do quite a bit with it. One of the challenges in this would be that for this to work, the customer must identify a host of information to the commercial laboratory for their database and trending to work. And by that, I mean would need to provide the make and model of the machine, the operating environment, the number of run hours, and so on and so forth, so that the statistics are properly provided. Short of doing this, it would have the potential of degrading the value of the recommendation that comes back. Now, in terms of an on-site laboratory, The options there would be to develop in-house expertise to the point that the commercial databases are not necessary, with the exception of the periodic sample where a second opinion is needed. Or there are companies that sell on-site laboratory testing packages, and these also include expert systems that will provide many of the same benefits of the commercial lab, but on a more limited basis. Turnaround time using an off-site laboratory requires collecting samples and mailing them in. Many of these laboratories have very, very good processes that provide sample bottles and labels and make it very convenient for the facility to mail the sample to them. But nevertheless, there is likely to be a couple of day delay to get the sample to the laboratory, and then agreements with the laboratory on acceptable turnaround time. That would be, is the testing done on a daily basis, or is there going to be a delay until the data is available? So the on-site laboratory can overcome this, and that same-day testing results are possible. However, there is also a limitation, and that would be that there sometimes can be limited staff, and all samples are not necessarily processed on the same day. So an on-site laboratory may actually have delays in their process just simply due to their availability of personnel and the priorities they might have. The machine environment, I would think that an on-site laboratory testing strategy, the people that are touching the machines will have the best knowledge of the machines, but the commercial laboratory sees more of these machines, and if the information is given to the commercial laboratory, can apply a deeper sense of statistics. Enhanced worker knowledge. Using a commercial laboratory, the facility relies on the commercial laboratory for the expertise, and this limits the development of the people and the depth of their understanding of the problems. This issue is not there with an on-site laboratory simply because they're more engaged with the machine and the testing. However, a real risk in having this type of a program is that a facility can develop a industry expert, can develop a fleet expert for their particular machines, and then that person decides that they want to get a promotion and get a better paying job, or they leave the company, or they retire. And when they do so, the expertise leaves, and that leaves a vulnerability for the facility. So ASTM does help with oil analysis. The Condition Monitoring Subcommittee of In-Service Lubricants has developed and issued many, many, many standards, and this has occurred primarily over the last 15 to 20 years. And I have just some examples, and this is not an inclusive list, but there are standards that provide information on the how to do it. A couple of them that I think are quite important. The D4378 and the D6224 are two standards that actually provide an overview of a program strategy, how often to do testing, what some of the common wear metals might mean, recommended actions, recommended test packages. That type of information is available. Also, some of the ASTM products will provide guidance on how to do this. Differences in test data. We have talked really a great deal, and I think Mindy did a wonderful job of developing this. To make good decisions for maintenance, one needs to start with good data. And part of that is understanding what testing is needed, and then also understanding what the range of acceptable data might be. And I'll give you an example. In a turbine, 1 or 2 parts per million change in wear metals can be very, very significant. A 1 or 2 ppm change in a gearbox is not significant. So the facility, the laboratory would need to be sure that the test that was specified is well aligned to the type of data that's needed. A precision of plus or minus 5 ppm would hide and mask problems in the turbine, for example. So I talked about similar type tests for wear metals. Wear metals, there are a great many different ways that one might measure wear metals. And this would be examples of that plus or minus 1 ppm or 5 ppm. But each of these has their value, and some of these are more expensive than other tests. And having a program structure to take advantage of the required level of precision and balance that with the cost of the data is very important to running an economical program. Okay, so some key takeaways. We are coming to the end of our presentation, and these all kind of read. So I'll say it's vital that the consumer of the test data understand the limitations and accuracy of the test data. I think we've made a very strong case for this. I think reacting to data of unknown quality is a recipe to making bad decisions. And when a program or when a facility invests a lot of money in a lubricant testing program and is operating on bad data, that's just plain and simple bad business. So I'd also commented about the failure mode relationship, and that would be that that it's very important to know why we're doing the testing. So if the oil analysis program has 3 tests or 5 tests or 8 tests on a particular sample, each of those tests should have a very clear purpose, and each purpose should be related to some element of the machine reliability and availability, or there's really no point in doing it. So the facility would need to have a good understanding of why they're doing what they're doing and what they expect out of each of the tests. And then the final point is that applying a strong condition monitoring oil analysis program it does, and it's very well documented, does improve machine reliability. It does improve availability. And if you back this up to the bigger maintenance picture, it certainly can defer and should defer maintenance costs that were previously incurred with repetitive maintenance. And it certainly should also address the corrective maintenance, in that it should reduce the amount of sudden onset or catastrophic failures that occur simply because the program is able to monitor these and help manage a more convenient time for the repair. Okay, so that's it. We certainly appreciate the opportunity to share our thoughts with the Gulf Downstream Association, and we hope that we've been able to provide value to your group. We covered a great many different topics over the last hour, and we would like to return this to Raj, and we would like to make ourselves available for any questions that any of you.
Thank you, Bryan. Thank you, Mindy. This has been a good, I would say, coverage and background to the quality of data, the importance of the good quality data for taking a good decisions on the machine which you are running in your plant, its health and its life. Thank you very much. I just had one thought before I open the floor to our subject matter experts for question and answer. I remember when I was doing in ADNOC risk survey and risk analysis of our assets in ADNOC. Often we used to ask for an outside party certificate for analysis, especially for like transformer oil analysis and so on, because that would give us some kind of authentication that the analysis has been done properly and it can be relied upon. The element of risk is that if you are doing it in-house and you could probably be complacent, you might not actually do it properly, you could probably be reporting or under reporting or over reporting depending on the situation. What's your comment on that?
Yes, thank you for the question. I think you raise a very valid point. I believe that point is something that any facility should consider. I would think that, that using the ASTM umbrella of tests will partially answer that. One element that many programs will do is they'll also take a certain percentage of their samples and send them out to a second source. And that could be if the facility is doing the work in-house or the facility is using a commercial laboratory. But by involving a second laboratory and then using the precision and bias information of the ASTM standards, one can fairly quickly tell if the data that is being used to make the decisions is accurate and usable, and that can happen relatively quickly. So I believe that provides a level of what is the word I'm looking for?
Reliability.
Comfort maybe to the
yes.
facility.
Right.
The commercial laboratories do have very extensive testing and certification programs. ISO 9000 would be an example. But even though I believe that the end user, because at the end of the day, the data that comes back requires the plant to make decisions and not the service provider.
Okay.
But even if a laboratory does have these things, it would be incumbent upon the facility to verify and accept the data and accept their process.
Thank you, Bryan. And I would now like to open the floor for Q&A. And I have a question from Air Liquid, Mr. Mahmood. Mr. Mahmood, would you like to ask the question, or would you like me to repeat your question? Mahmood, if you are there. Yeah.
Thank you, Raj. Thank you for this good presentation. And in fact, my question is regarding for the quality assurance and quality control. So my question was, normally we are doing this oil analysis using the commercial labs, and we don't have any criteria how they are accurate in their data, and we don't know how they are doing their quality control. So how we can, or how we ensure that they are in the good track of the quality control and be comfortable with the data coming from them.
So, I mean, most commercial laboratories will provide you with some sort of certificate of analysis that offers what procedures were done, at what capacity, at least with, temperatures, established loads, anything that needs to be, any parameter that goes along with the test method is generally provided at the same time. So if you don't have that information, you can certainly request the laboratory to provide that for you. What that does is that gives them some sort of reassurance that the method was performed as required. In the sense of an ASTM method, you would know exactly what the reproducibility or the precision would be, so you would know, you would have a reasonably good feeling for what the data should look like the next time, provided there's nothing adverse with the sample going on. But laboratories that generally run ASTM methods, they have to produce some sort of quality assurance that shows that they participate in other avenues for quality control, such as ASTM internal study, round robin studies. There's other methods, there's other mechanisms by which the laboratory could produce data and show good quality control. So if they're not putting it on there now, you're more than welcome to ask what methods they utilize. That way you can know what the variability might be.
Yeah, it's quite clear. Normally here in our region, they are saying we are comply with ASTM standards, we are comply with ISO 9000, and that's it. But when we ask them more deep, the response is not as you are expecting. Sometimes like that.
Yeah, I understand that it gets confusing on how much information to relay, but as we mentioned, there are plenty of ASTM methods that take into account reference material. There's even if you don't have a reference material, you can establish a reference material. I know that in many labs that I'm aware of, if you don't have a particular accepted reference value to compare test results to, the laboratory will generally establish one. That way they can do the variances and the tolerances every day when they're setting up their instruments and their test procedures. They've got something to go off of, just to make sure that their instruments are operating appropriately. So, they should be able to answer some of that information. Yeah, but at least knowing that they have those certifications certifications, the ISO 17025, that does put some sort of requirement on what kind of quality controls they must
Yeah.
adhere to.
Very good. Mindy, I have a follow-up question which actually comes from Mahmood only. How do you ensure that what they have provided in certificate is accurate? For example, if suppose they didn't conduct or didn't comply with ASTM standard, only simply said that they have complied, and do you have any policy or procedure to take action against such non-compliance and non-accurate reporting?
Yeah, that's a difficult question, or a difficult question to answer. I mean, all you can really do is inform the user that you're not looking at similar methods, and so there's quite a bit of variability that might be involved. I mean, generally, if you're looking at similar methods between different laboratories, you're already looking maybe 5 to 10% variability. So if you bring in a different method altogether, I mean, this could be quite large, but it's not up to the laboratories to make that inference about the non-qualifications, but all you can do is suggest that the methods are just not quite the same, and you have to go back to the standardized method in order to allow for that comparison result. But otherwise, all you can really tell somebody is that they're just not the same methods, and that there's going to be quite a bit of probably some good variability. Now, there's some properties that just aren't going to change, and it doesn't matter how you do it. Like the density of the material, it really doesn't matter how you run that test. You're probably going to get the same data in various different ways that you do it. But there could be other properties that bring into such like contamination that Bryan was talking about, where you kind of need to do it the exact same way in order to compare what you see on site and what you might see between different labs, because without the exact comparison, your data could be very variable. So Bryan, you might have something to add to that.
Yeah, thank you. I think what I'd like to add to that is that at the end of the day, any data that we look at is really our responsibility. So if I'm the consumer of the data, if I'm the plant, and I'm contracting the service, commercial lab, or I'm doing the testing on site, I still need to decide if the data is good or not. It's not really the lab's responsibility. So how do you do that? Well, one way to do that would be to perform an audit of the laboratory. And I think this is not a bad idea for the service that you're employing, to take a trip to the facility and spend a day or two with them and have them explain to you why their data is good and what their practices and policies are. And I would believe that any respected laboratory would welcome a customer that wants to make that investment in time to go find out what their service provider's policies are. And do they actually follow the ASTM standards carefully, or do they not? That's something that you can very quickly establish. Now, the other part about that is that while you can do an in-person audit, one can also do an audit remotely. And the way you do that is that you take samples, and if you have concerns about the samples or they seem different, those are the ones that will really show a difference from laboratory to laboratory. But a sample bottle can often contain quite a bit of oil, and that sample bottle could be split into 2 or 3 parts. And a second laboratory or even a third laboratory can be brought in for the same test. And all of these laboratories, if they are claiming to use ASTM processes, should produce data within the ASTM standard. And so if the laboratory you're using is an outlier and really not carefully following the process, your testing process of auditing with your own samples will also show that. So I believe the end user does have a couple of options to decide, am I getting good data? And I think it's a very good business if you're spending the money that you're spending on your program regardless, to have a good understanding of what that data might be. So a program such as this is also something that would need to be periodically reperformed. So sending out one round of samples and saying, well, I'm done, I've done it once, I'm happy with the lab, doesn't mean that, all of the laboratories will continue with the same level of rigor. Even in some cases, you wouldn't want to tell a laboratory that what you're doing, that you're sending them a quality sample, you send them a regular sample and see how they do. So I think every laboratory needs to have a certain population that involves a third party, and then this needs to be used to anchor the data better.
Good afternoon, and thank you, Bryan and Mindy, for very excellent and informative presentation. And I think with condition monitoring, probably we need it these days because it will lower our cost, which is needed morely these days. My comment or question, I know there is American Association for Accreditation, and the well-known laboratory are accredited, isn't it? Usually the well-known American laboratory, they are accredited by this association, isn't it so?
Well, I'm not familiar on all the accreditations that any laboratory could have, but certainly doesn't hurt. But each accreditation is looking for something very specific. So utilizing something like an international or an ISO or some sort of quality management system might, if you can meet the bigger one, you probably meet some of these other accreditations. But I don't know that by not having the accreditation, that doesn't mean the laboratory is not established or doesn't have good practices. So I think there's various ways that you can go about having accreditations and different accreditations, but certainly doesn't help. I mean, like I said, some of those accreditations are very specific, like I'm not familiar with the one that you were discussing, but they could have very specific requirements to one thing that another accreditation doesn't find quite as controlling. So that doesn't necessarily mean that they're not a good fit for you or a good laboratory to utilize. It just means that the accreditations are geared to something more specific.
Okay. My name is Mohammed Al-Moaili. I used to work for Saudi electricity company for a good number of years, which is, I think, more than 22 years. Recently, I joined a company called GCC Lab, which is still owned by the Saudi electricity company and other companies such as Saudi Aramco. My question is, Saudi electricity company now, they are shifting from time-based to RCM, reliability centered maintenance. Of course, going through a condition base to build their database, etc. Recently, they are working in AI, artificial intelligence, to be installed on their major equipment, transformers mainly, and they are heavily depend on the oil analysis to be the key factor of analyzing the condition of the unit to make sure whether the transformers is healthy or not healthy. The online monitoring, they are using artificial intelligence, which is self-learning. I mean, software. The software itself will know the unit is under loading condition or half loading condition, or whether it's having some circumstances or condition that may impact the quality of the oil. The question is ASTM with a new technology, new software, new artificial intelligence, considering these new technology to help, I would say, the technology providers in order to judge the healthiness of the equipment, because nowadays it is not a lab test result that you can compare your test result with a certain limits issued by ASTM or something. It is some sort of dynamic things that you have to take a decision on spot.
Thank you, Muhammad. I guess you are referring to the artificial intelligence installed on the data collected online from the transformer oil.
Yes,
Is that?
yes,
Yeah, but the
yes.
data test data will be fed by some laboratory, right?
No, it's not because it is like an online sampling.
Ah,
The technology will take the sample, which is mounted on the transformer set. The samples will not be taken to the lab.
okay.
The sampling rate is a sample each hour. Then the technology will test and get the result as a one input, and also another input is coming from the transformer temperature of the winding, the loading. It's some sort of complicated algorithm. All of these, they will go to one point and tell you whether the transformers is healthy or not. Such a flow of a huge number of data that will pass at a very small time. I don't know with the new technology. I don't know if ASTM is considering this because nowadays maybe the old standards so will not help. Currently, as I said, we are helping Saudi Electricity Company on their journey to move from time-based to total RCM.
I was just thinking, Bryan, this sounds a lot like some of these inline sensors that that we do have, methods for. So ASTM does address using some of these products in-house, but so it's not an I think we definitely do think about the future and what's coming and what's down the line now. It could be, what makes ASTM methods so valuable is that they do put a lot of work into utilizing or into determining what the data is at various places. So you've got to have a lot of people utilizing the system in order to figure out how reliable they really are, or at least how, one system could be operating differently than someone else's system. So I think they do take that into consideration. I don't know if we have this particular one insight. Of course, Bryan and I don't necessarily work with the Transformer group, but they do come into play. And Bryan, you may have more to add to that.
Yeah, and thank you, Mindy, for that. Yeah. So this is an emerging area. If you go to the conferences and meetings, you'll find many vendors that are beginning to sell expert systems that do online sensing. So the in-service community within ASTM does have a handful of standards that are on the books that relate to that. In terms of a more global, of taking 2 or 3 or 4 of these things, I don't know that that's a mature process yet. I think it's building. There are some instruments, however, some online or some in-house instruments that one can buy that have software like that built into them. So a challenge with this would be again, accepting the expert rules and accepting that the expert rules are being applied correctly. And this again falls to the companies that are purchasing this to do due process on the data and to vet the data and to do audits and to send samples to other facilities and get the test data back and do their own evaluation if they choose to accept it or not. So ASTM, to answer the I guess the underlying question you have, does ASTM certify these expert systems and whatnot? And the answer on that would be no. But elements of this are beginning to come in, and I don't know that we'll ever be in a situation where it wouldn't be wise to go after the data and make sure the data is going to work for you. And part of that, and I go back to one of the benefits of having in-house testing would be to be able to evaluate the data. You need to know what the data is and be able to understand it. If you use a commercial laboratory, I would think that each facility should have their in-house expert that is the point of contact with the commercial laboratory. And that person should have a very, very good relationship with the commercial lab, should have their expert on speed dial, and should be very assertive and contact them and say, what does this mean? I don't understand this. Why do you recommend this? And then that discussion can help the commercial laboratory look at their assumptions and see if they're appropriate. I had mentioned earlier that one of the challenges that a commercial laboratory has is getting enough information about how the machine runs and even what the machine is. And having this very close alliance with their expert, and Mindy is one of these experts in a commercial laboratory. So having Mindy's telephone number is very, very valuable. And my company from time to time does use Mindy's services, and for those cases, Mindy is my expert when I need to reach out to somebody. So that's just good business to have that.
With that, let me close this conversation by thanking ASTM in general, and Bryan and Mindy in particular. Definitely, you both have done a great justice with the topic and benefited our members and the viewers. And as you know, the viewers, GDA has been conducting these conversations over the last few months. We have already connected with many industry leaders and subject matter experts. Please go to our website to see all the previous conversations and take benefits from them. And for this conversation, if you have any question to Bryan or Mindy, please do write to us through our website info, and we will try to get the answers from them and back to you. With that, if you wish to download this presentation, we have the permission of ASTM to let you download this through a link which will be posted below this YouTube video under the description, and you could download it from our website. So with that, once again, thank you very much for being with us and be part of the GDA conversation. Stay safe, stay healthy. Thank you.
Goodbye.
Thank you, Raj.
Thank
Thank you,
Thank
everybody.
you. Bye-bye.
Thank you very much. Bye.